All right, so the first exercise, we have a 2 pi periodic function. So f equals minus modulus of x, and our interval is minus pi to pi. Okay, so the first question is to represent the function f. So we're gonna basically just draw the graph. So our function is f of x equals minus modulus of x. So if we only had modulus of x, the function is well known, is basically a v. So it's a pair function. And since we have this minus here, we're just gonna invert the graph. So we're gonna invert the signal and we'll have an inverted v here. So it will form something like this. So that's the representation of our function. So it goes from minus pi to pi, and we'll reach the value here. The value is minus pi. So what we've got here, we've represented it on an interval of 2 pi, but our function is 2 pi periodic, so it means that the structure that we've represented here, it repeats infinitely. So to answer the question properly, we can put 3 points here and 3 points here to indicate that the function, this structure will repeat to the right and to the left. So it would go something like this, endlessly, to both sides. All right. So, okay, that's the answer of the first question. The second question is to calculate the Fourier coefficients and write the sum of Fourier of the function f. All right. So, second exercise. In order to calculate the Fourier coefficients, in general, we first do a little analysis about the parity of the function, because we're not necessarily gonna need to calculate a0, an, and bn, because if we identify that the function is pair or odd, some of those coefficients will be immediately zero, so we won't have the work, so we won't struggle to integrate something and at the end we reach in zero. Okay, so looking at our function here, we can see that it is clearly pair, since it is based on the function modulus, and the function modulus is a pair function. Another way to know that is just looking at the graph that we've represented here. Everything that happens on the right happens exactly the same on the left. So the idea of a pair function is f of x equals f of minus x, and we can see that clear. So if we have like pi divided by 2, just for an example, we have this value of the function, and if we pick minus pi divided by 2, we reach the same point. So it is exactly the definition of a pair function. So it means if we pick a point x and look at the f of x, we'll reach the same f of x if we use the point minus x. So that's the idea. So since we have a pair function, so it means immediately that Let's see, it means that Bn equals 0. So if you want a general rule, I'll explain it later, but the general rule is if your function is pair, then Bn equals 0. And if your function is odd, then you'll have a0 equals an that equals 0. So that's the general rule. You can know that by heart, it will help you. So now I'll explain the logic of it, but in the context of just solving exercise, you'll only need this. But I guess the logical part is important as well, so I'll explain it right now. All right, so let's write the formula of Bn. It equals 1 divided by pi integration from minus pi to pi of f of x times sine of nx dx. So that's the equation of Bn. So let's analyze this. The sine function is an odd function, so this is odd. F of x, let's assume it is pair, so it's the case of the exercise we're dealing with. So let's say this is pair. So here we are integrating a product of a pair function and an odd function. So odd times pair function, that equals an odd function. So if you want to know, just to make everything clear, pair times pair equals a pair function. Odd times odd equals a pair function. And odd times pair, that means an odd function. So that's basically how things work when you multiply functions. So if you have a pair function and an odd function here and you're doing this product, you reach to an odd function. And if you integrate an odd function on a symmetric interval, then you'll have 0. And why that happens? Let's do a graph of an odd function. So if you had a pair function, everything that happened here on the right would happen the same on the left. The concept of an odd function is it is like a pair function, but you'll invert the signal of half of it. So if you do this on the right, if you had a pair function, you will do this, but you will invert the signal, so you'll have this. That's a pair function. Okay, so let's assume here a point A, for example. Here we'll have minus A. Okay, when you integrate from minus A to A, you're just calculating the area. That's basically integration. You're calculating the area. But since in modulus, in absolute value, this area equals this area, and here you have it negative, and here you have it positive, you're basically just adding the same areas but with inverted signals. So you will reach 0. So that's why if you integrate on a symmetric interval an odd function, you'll have 0 as a result. And if you're integrating a pair function, so let's say this pair function will be something like this, on a symmetric interval, so you'll have this, you're calculating the area. Since it is a pair function, it means that this area is the same as this area. But here they're both positive. So if you're integrating a pair function on a symmetrical interval, what you can do is you can reduce the interval in half, so you're not integrating more between minus a and a. You're just integrating between 0 and a. So you cut the interval in half. And then here is your function. And you multiply it by 2 because it is the same area. You're just cutting in half the interval and multiplying it by 2. So you could just do the regular integration. The result is the same, but you'll need to put more effort. It will be harder because you'll do like sines or cosines of minus pi divided by 2 minus pi. It can be a little bit different. It can be a little bit difficult and you could do mistakes. So it's easier if you know by heart that if you're integrating an odd function on a symmetric interval, you have 0. And if you're integrating a pair function on a symmetric interval, you just multiply it by 2 and cut the interval in half. All right, so that's the explanation of why things happens like that. So during this exercise and in the other videos of other exercise, I'll just assume that this will happen and I'll do it naturally because it will make things easier. But the explanation of why I'm doing that and how I'm doing that, I just gave. Okay. All right, so I just erased everything and let's continue the exercise. So since f is a pair function, then bn equals 0. So I guess it's clear now. And now we need to calculate a0 and an. So let's start by an. Okay, so the formula is 1 divided by pi, integration between minus pi and pi of the function f of x times cosine of nx dx. All right, so since f is pair, cosine is pair times pair equals pair, we are integrating a pair function on an asymmetrical interval. We can cut the interval in half and multiply it by 2. So that equals 2 divided by pi. So the interval of the integration will be 0 to pi. And here f of x cosine of nx dx. All right, so what is our function when f of x is positive? Because right now we are integrating between 0 and pi, okay? So our function is f of x equals minus modulus of x if our interval that we are integrating is positive. It means that modulus of x equals x. So this will be minus x with this minus here, and we cut out this modulus. So when we cut out, we stay with minus x. Okay, so that's our function f of x here. So let's continue. I will take this minus out of the integral, so we'll have minus 2 divided by pi, integration between 0 and pi, of f of x now is just x cosine of nx dx. So right now we'll have to do integration by parts. I will do it directly. I actually advise you to stop the video and try to do it by yourself. But basically the formula that we're gonna use is integration of u dv equals uv minus integration of v du. So that's the formula. I'm gonna do it on a direct way. Okay? So we have minus 2 divided by pi. And here we'll have x times sine of an x divided by n. So this will be the uv. That's my uv. And that goes from 0 to pi. And we have here minus the integral of the derivative of x, that is basically 1, sine of an x dx. The division by n here, I will take it out of the integral. So let's make it right this. So I guess that's right. Let's hope it is. All right. So let's continue. This will be minus pi divided minus 2 divided by pi. This will be 0 since we are going to substitute pi or 0 inside a sine function. Sine of pi equals 0, sine of 0 equals 0, so it doesn't matter. This whole term equals 0. And we'll only have minus 1 divided by n, and we're integrating from 0 to pi sine of an x dx. Okay, so this minus cuts out with this minus here. So let's just put 2 divided by pi. Let's add here our n. So we have 2 divided by pi n. And now let's integrate sine of an x. So the integration of sine of an x equals minus cosine of an x divided by n, goes from 0 to pi. So developing this, we'll have 2 divided by pi n squared minus cosine of n pi plus cosine of n times 0. So this cosine of n times 0 is cosine of 0. That's basically 1. And here we have minus cosine of n pi. So cosine of n pi equals minus 1 to the power of n. So why that? Okay, so let's just do a quick draft here. All right, so if we have n equals 1, we'll have cosine of 1 times pi. So we have cosine of pi. Cosine of pi equals minus 1. If we just remember about the trigonometric circle, pi is here. So we have cosine of pi. Cosine is the horizontal line. So we'll have minus 1. Okay, here is 0 and here is 1. So pi is this angle here. So we'll reach minus 1. So n equals 1. Cosine of pi minus 1. Okay. So if n equals 2, we'll have cosine of 2 pi. 2 pi is basically the whole circle. We'll reach 1. So this is 1. If n equals 3, we'll have cosine of 3 pi. 3 pi is basically a whole circle plus half a circle. So we'll reach the minus 1 again. So we'll have minus 1. And if you just do this repeatedly, it will be clear for you that we are just alternating between minus 1 and 1. So it is the same as writing minus 1 to the power of n. Because if we have n equals 1, we have minus 1 to the power of 1. So we'll have minus 1. That's basically what we have here. If we have n equals 2, we will have minus 1 squared. That's 1. So that's what we have here. So it's just the same logic, okay? But written on a different way. All right, so that's a way of simplifying our Bn. So we will use this, okay? So this is 1, and this is minus here, okay? There's a minus here, so minus. And cosine of n pi equals minus 1 to the power of n. This minus here can go to the go along with the n, so that's basically minus 1 times minus 1 to the power of n. So we can just add 1 here. And well, that's it. Okay, so let's simplify it. It will be 2 divided by pi n squared times minus 1 to the power of n plus 1 plus 1. So right now, if we analyze this, if we have n as an odd number, we'll have n equals 1, n equals 3, n equals 5, go on. Okay, so if n equals 1, we'll have here minus 1 to the power of 2, so minus 1 squared. This will give us 1, so we'll have 1 plus 1, 2, 2 times 2, 4, so we'll have 2 divided by pi n squared. Okay, if we have n equals 3, we'll have minus 1 to the power of 3 plus 1, that's minus 1 to the power of 4. That's 1. 1 plus 1, 2. 2 times 2, 4. So 4 divided by pi n squared. This will happen for all odd numbers. So if n is odd, then our Bn equals 4 divided by Pn squared. Okay. If our n is pair, we'll have minus 1 to the power of 0 plus 1. That's minus 1 to the power of 1. That's just minus 1. Minus 1 plus 1 equals 0. So we'll have 0 as the value of Bn. N equals 2, minus 1 to the power of 3, that's minus 1, minus 1 plus 1 equals 0, and that goes on. So if our n is pair, our Bn is automatically 0. So what's happening here is we are trying to calculate, to write down an expression for Bn, but if our n is pair, it's not adding any value to our Bn because our Bn equals 0 every time our n is pair. So a way of simplifying our expression of Bn is restricting n as an odd number and then rewriting the expression of Bn. So what we're gonna do is we're gonna change our variable. So n goes from 1, 2, 3, 4. It's basically the natural numbers, excluding 0. So that's our n. So we're going to change this variable. We are going to write down n equals to L plus 1. So what we are doing here is we are changing the variable. And by doing that, we are forcing n to be an odd number. When we write 2 times a number, we are forcing it to be pair since it is you can divide it by 2 because the 2 just cuts out. Okay, so this is a pair number, and when you add 1, it forces the number to be odd. So mathematically, when you write that a number equals 2 times another number plus 1, you're forcing this number to be odd. So that's what we're gonna do. So n equals 2l plus 1. And now we'll simplify our expression. So we'll have here 2 divided by pi n squared, but n is 2l plus 1, so 2l plus 1 squared. And here we'll have minus 1 to the power of n plus 1, but n is an odd number, so minus 1 to the power of n plus 1 equals 1, since the n is odd, and we've already analyzed the logic, so it is 1, so 1 plus 1 equals 2, 2 times 2 equals 4. So you just erase these 2 and put 4. So when add is odd, that's our Bn, or that's our B2L plus 1. Okay, so that's the final answer. And I know it is a little bit difficult to understand what we've done here, but that's very frequent in a lot of different exercises. And the thing is, we're just separating. Our Bn is based on all values of n. So that includes odd numbers and pair numbers. But sometimes, and actually on a lot of times, or the pair numbers are not going to contribute, or it's not going to add any value for our Bn or An, or the odd numbers are not going to contribute. So we need to analyze what's the case and just exclude the numbers that are not contributing with anything. And that's a way of simplifying the expression of Bn or An. So it depends. But in our context here, if we had a pair value for n, we're just adding 0, 0, 0, 0 for all pair numbers of n. So we just simplify it by doing a change in our variable, and that excludes all the cases that we are just adding zeros. Okay, so that's basically it. And all right, so we have here our bn equals 0. And oh, I'm sorry, that we were not calculating bn, we were calculating an. So now a to l plus 1. And now we need to calculate our a0. Right, so calculating the value of a0 is way easier. We just need to integrate 1 divided by pi from minus pi to pi f of x. And, well, f of x is pair. We can multiply it by 2, cut the interval in half. So 2 divided by pi, integrating from 0 to pi. The value of f of x is minus x. So we'll have minus 2 divided by pi, integrating from 0 to pi, x dx. So that's minus 2 divided by pi, x squared divided by 2 from 0 to pi. So we'll just substitute the value of pi because, well, 0, we're going to get 0. So minus 2 divided by pi times pi squared divided by 2. So the 2 cuts out, so just erase it. And the square cuts out with this pi, so we'll only have minus pi. All right. So now we have a0, an, that's now a to l plus 1, and bn, that equals 0. So we have all the three coefficients. We can write down the sum of Fourier. So the sum of Fourier, I write down the structure, the general structure. It is equal to a0 divided by 2 plus the sum of n going from 1 to infinity of an cosine of an x plus the sum of Bn sine of an x. Okay, so our Bn is 0, so this whole sum is 0, so just erase it. Our a0 here is minus pi, so we will have minus pi divided by 2. Our sum here on the general structure, we have n starting from 1. Now we have L, and our L is going to start from 0 because we go back here to our to the moment that we change the variable. So if we have 1 here, let's write 1. It cuts out with this 1 here, and we'll have L, 2L equals 0, so L equals 0. So because of the fact that we've changed variables, our sum will start at L is greater or equal to 0. Okay, we need to change that since we've changed the variable. So our an will be the a2L plus 1. So we just put the value that we've found. So 4 divided by pi is constant. I'll take it out of the sum. And here 1 divided by 2L plus 1 squared cosine of an x. So that's the sum of Fourier for our function. So I guess that right now we've answered the second question. So we've represented the function, we've calculated all the coefficients, and we've written down the sum of Fourier of the function f. All right, so let's see the question 3. Here we have to calculate this sum here on by two different ways. So okay, so the standard procedure is you look at the sum that you have, look at the sum that the question is asking for. It probably will have similarities if you've done everything right. But there will be some terms that need to vanish, some terms that need to be modified, and you're gonna try to do it, okay? So let's come back to what we have. So we have this. Here we have 1 divided by 2L plus 1 squared. That's exactly the sum that the question is asking for. But here we have a cosine of an x, and we need to make it vanish. So how we do that? We're going to use the Dirichlet theorem. By using the Dirichlet theorem, we're just picking a value of x, and we're gonna use this equation. So Sf of x. Here we are gonna insert the value of x that we need to choose, and that's equal to the value of the function coming from the right plus the value of the function on that point coming from the left divided by 2. Okay, so we need to choose a value for x. If we want the cosine to vanish, a good point is 0, because if we have x equals 0, we have cosine of 0, that's 1. So we'll only have the sum of 1 divided by 2L plus 1 squared, and that's exactly the sum that the question is asking for. So the point that you're going to choose, it depends on what you have and what you want to transform what you have on, based on what the question is asking. Okay? So let's use Dirichlet on the point x equals 0. Okay? So if x equals 0, we'll have Sf of 0, that's minus pi divided by 2, plus 4 divided by pi, the sum of L greater or equal to 0 of 1 divided by 2L plus 1 squared times 1, because cosine of 0 is 1. Okay, so we've written down our sum of our function substituting the value of x as 0. Okay, so I'll just erase this times 1. Okay, and now we need, following the equation of Dirichlet here, we need to find the value of the function on the point 0 coming from the right plus the value of the function on the point 0 coming from the left divided by 2. If we go up to the graph that we've withdrawn, if we follow from the right, so following from the right, we're going to follow our graph here. We'll reach the point 0 and we will find 0. If we come from the left, we'll follow our graph here and we'll reach 0 as well. So that happens because we have a function that is continue on the point that we've substituted. Okay, so when that happens, we can simplify the equation of Dirichlet as simply Sf of x equals f of x. So that's a simplification of the Dirichlet equation, and we can only do that when we are substituting a point where the function is continue at. Okay, so continuing here, we'll have minus pi divided by 2 plus 4 divided by pi, the sum that the question is asking for, and that's equal to 0 plus 0 divided by 2, that's 0, or simply the value of the function on the point 0, that is 0. Okay, so minus pi divided by 2 goes to the other side as positive, so 4 divided by pi, the sum equals pi divided by 2. And then we're going to multiply this pi here. We'll have pi squared. And we're going to divide this 4 here. We'll have 2 times 4 here, so 8. So that's the value of the sum that the question is asking for. All right, so if we look at the exercise once again, we have here deux façons différentes, donc we need to do it on 2 different ways. So we've used Dirichlet on the point x equals 0, it worked. So now we can use on another point that will once again make this cosine of nx disappear. So another point that we can use is pi, because if we use pi, we have cosine of n times pi, that's minus 1 times, let's write it down, cosine of n pi equals minus 1 to the power of n. We've already discussed that. But here, we've already changed our variable. So we won't have minus 1 to the power of n. We will have minus 1 to the power of 2l plus 1. That's an odd number. If we had an odd number, minus 1 to the power of an odd number equals minus 1. And this minus here, we can take it out of the sum. So basically, we'll reach to what we wanted to do, to what we intended to do, that is vanishing this cosine. Okay, so let's substitute and things will get more clear. All right, so let's use now the point x, it is equal to pi. All right, so sf of pi equals minus pi divided by 2 plus 4 divided by pi, the sum of L greater or equal to 0, 1 divided by 2L plus 1 squared. And here we have cosine of n pi. Let's put minus 1 to the power of 2L plus 1. Okay. And well, that's equal 2 minus pi divided by 2 plus 4 divided by pi. The sum that we want. Here, minus 1 to the power of an odd number. This will give us just minus 1. And if we want, we can take this minus 1 out of the sum. So I'll just erase it, and I'll put here a minus. So we have minus 4 divided by p times the sum. Okay? And once again, we'll use Dirichlet. So here, looking at our graph, if we come from the right, let me erase this in order to delete confusions. Okay, if we come from the right, the graph will be like this. If you're coming from the right, we're gonna reach this point. That's minus pi. Okay, reaching the point pi, f of x values minus pi. If we come from the left, so from the left, come from here. So we're coming from the left and we're reaching at the point equals pi, the same point that equals minus pi. Okay, so once again, our function is continuous at the point that we are substituting the value of x. That means that we can simplify Dirichlet as just the sum of Fourier of our sum on the point that we've chosen, pi, equals the value of the function on this point. So let's write it down. Here it's basically f of pi. So that's the simplification of Dirichlet. And that's equal to minus pi as we've calculated. Okay. So minus pi plus pi divided by 2, we just switching sides and switching the sinus. So minus 4 divided by pi, sum that we want, equals minus pi plus pi divided by 2. That's minus pi divided by 2. Now we can just erase these both negative signs here. And once again, multiplying by pi, dividing by 4, we'll reach the same result. Pi squared divided by 8. So we've used Dirichlet on two different points to reach the same result of the same sum. Okay. At the first one, we didn't have any discontinuity on the point that we've chosen. I guess the point was x equals 0. And now on x equals pi, we had discontinuity. So we needed to use the more generic, the more primitive formula of Dirichlet. And well, we've reached to the same value. And I didn't write it down to save time, but I'll say it right now. If you're using Dirichlet, you need to state three things. You need to say that your function is 2 pi periodic. You need to say that your function is C1. That means you can derivate it at least once. And you need to say that your function is continuous. Okay? The continuity and the fact that you can derivate it once, it can be by parts or simply in general, not by parts. On this case, we have a function that is continue for all values of x. There's no discontinuity. So when you write it down, you just say that your function is 2 pi periodic, it is C1, and it is continue. No need to add the par morceau. Okay? If your function wasn't continue at all points, you need to add the par morceau part. Okay? So that's it. All right, so question 3 is over. We need to solve 4 right now. It wants the value of another sum. So here we have the power 4. It will get more. You'll develop the instinct of which theorem you need to use to solve the questions. But the power 4 here indicates that you need to use Parseval. So you'll just straightforward apply the theorem. Okay. So for question 4, let's use Parseval. So in order to use Parseval, you need to justify all the 3 topics that I've already set to the Euclid. So 2 pi periodic, C1, continue, and you need to add that your function is inside the space of L2 of the real numbers. Okay, you need to state that. Now you can use Parseval. So the first thing to do is to calculate the 2 norm squared of your function. That means 1 divided by 2 pi, and then you're gonna integrate from minus pi to pi your function squared, dx. Okay, so f of x is pair. A pair function squared is pair times pair. That's a pair function. Symmetric interval, you can multiply it by 2. So this 2 here will cut out. So we have 1 divided by pi. The interval cuts in half. The value of the function f of x from 0 to pi is minus x. So you'll have that squared dx. Minus x squared is equal to x squared. If you integrate this, you'll have x cubed divided by 3 from 0 to pi. That's basically 1 divided by pi times pi cubed divided by 3. This pi here cuts out with the 3, so we have a 2. So pi squared divided by 3. Once you've calculated your 2 norm of your function, you're gonna substitute on this other formula here that says that the 2 norm of your function squared equals to a0 squared divided by 4 plus 1 divided by 2, the sum of an squared plus bn squared. So our bn is 0, so this is 0. And we have all the other values, so let's just substitute. So the 2 norm squared equals p squared divided by 3. Our a0 is minus pi, so minus pi squared will have pi squared divided by 4 plus 1 divided by 2 times our an squared. What is our an? We've calculated here. So if we square this, we'll have 16 divided by pi squared, and here to L plus 1 to the power of 4. So 16 divided by pi squared, and here at the sum we'll have L greater or equal to 0, and 1 divided by 2L plus 1 to the power of 4. So now we have the sum that the question is asking for, and we have all the other values, so now it's just algebra and we'll reach to the result. So half of 16 here is 8, so let's erase the half, put an 8 here. All right. Okay, so let's do this. We have here at this side pi squared divided by 3 equals pi squared divided by 4 plus, so we'll have a minus here and an equal here. I just switched sides for the pi squared divided by 4. This will give us 12 divided by 3 equals 4, minus 12 divided by 4 equals 3. So pi squared divided by 12, that's basically the math here. So I'll just erase it and put pi squared divided by 12. Okay, and now we need to multiply it by pi squared and divide it by 8. Okay, so if we multiply it by pi squared, we'll have pi to the power 4. And if we divide it by 8, we'll have 96 as our denominator. Okay, so that's the final answer for the value of this sum here.